Okay, so now we're going to talk about a more formal definition of a limit. In this particular case, the limit is defined this way, and this is due to Augustin Louis Cauchy back in the 1800s who defined this. He said, let f be a function that is defined on some interval containing a number c, except possibly at that point c, and let L be a real number. The statement, right here, the limit as x approaches c of f of x equals L, means that for every epsilon greater than 0, there exists a delta greater than 0 such that if x minus c is greater than 0 but less than that number delta, then the distance between f of x and L is less than epsilon. Now you might be thinking to yourself, that's crazy talk. I don't know what he means. Well, let's see if we can help straighten it out. And we're going to do that using the graph of y equals 2x minus 1. Now we know basically what happens at 2x minus 1 right here. The coordinate point that we get rid of that whole point there, there you go. It should be 5, 9, right? If we put in x, y equals 9. So what we really want to try and do is we really want to try and verify using this definition what is meant if we say, I'll write this out, that the limit as x approaches 5 of the quantity 2x minus 1, that we get the value 9. So we're going to try and verify that using this definition. So what we're going to do is we're going to verify this statement is true using this definition. We're using the bottom part of this definition. I'm going to start backwards. I'm going to say, all right, there should be some number epsilon greater than 0. So let's pick a really small number. Let's say epsilon, that's lowercase Greek epsilon, is 0.01, right? We want to say if there is some small value epsilon like 0.01, there should be some related small value for delta such that x minus c is greater than 0 but less than that number delta. So here's what we do. Let's start with this end right here. F of x. Well, f of x, what is that? F of x is the quantity 2x minus 1. And we're going to subtract from that the limit L. The limit L in this case is 9. Right? And we're saying that that is less than some value epsilon. In this case, we're going to specify. Let's say what happens if it's 0.01. All right, so let's do a little bit of algebra magic right here. We know that absolute value of 2x minus 1 minus 9 is really the same thing as saying the absolute value of 2x minus 10. All right. Now, here's the thing. When we're dealing with an absolute value bracket, we can do the following. This is going to be the same thing as saying 2 times the absolute value of x minus 5. If you have trouble seeing that, remember that 2 times the quantity x minus 5 is equal to 2x minus 10, and the absolute value of 2 is equal to 2. So we're just taking that 2 out, and we're saying that's less than 0.001. Right? So now what does that mean? Well, if we take this quantity right here and we would divide both sides of this inequality by 2, we would find that the absolute value of x minus 5 is less than 0.005. And you're asking yourself, well, what does that really mean? Well, as long as this value is greater than 0, this is true, right? So how is that related to this? Well, it kind of looks like this statement right here without the greater than 0. But let's specify, okay, it must be greater than 0. That means that x cannot equal 5. We're just interested in what happens when x gets close to 5. And so if we look at this statement, we're saying that, all right, if we picked our value y equals 9, our limit is 9, we're saying right here. We're building a little radius around y equals 9. And that little radius actually goes between 0.01 above, so 9.01, and goes as low as 8.99. And so this statement says, this algebra that we just worked out right here states that as x gets close to 5, right? So the distance between x and 5 is less than 0.005. So we're saying, okay, so there's some related interval 0.05 away, right? So 5.005 here and 4.995 here. And we're saying that as long as we pick an x that is somewhere within this interval, although not exactly at x equals 5, we're going to get a y value somewhere between these two y values here, right? So in fact, this does verify with our formal definition of the limit that as x approaches 5, as long as we're within 0.05, at least in this case, y will be within 0.01. Now again, there was no particular reason that we had to choose 0.01. We could have chosen 0.001 or made that number epsilon as small as we please. But we're saying that for whatever epsilon we pick, right, if we divide that number by 2, what it looks like right here, we're going to get whatever value delta goes with it. And so there's actually a relationship between epsilon and delta. And therefore, for every epsilon we pick, we're going to get a delta that's half that size. And so there's always a value of x within that delta radius of 5, such that y is within the epsilon radius of 9.